Right now, if you sleep 8 hours tonight, you'll spend close to 2 hours of it dreaming. Somewhere in there, you might be chased. You might fly. You might have a conversation with someone who died years ago, and for the length of the dream, it won't feel strange at all. You might not even question why a familiar room has the wrong number of doors, or why your childhood home is somehow also your workplace. Inside the dream, none of it registers as impossible. Only afterward, blinking at the ceiling, does any of it sound insane out loud? By breakfast, you'll remember almost none of it. Not a little. Almost none. Studies suggest you forget around 90% of a dream within just 10 minutes of waking up. Not because the dreaming stopped mattering, because forgetting might be part of the design. For decades, one theory dominated popular thinking. Dreams are just noise, random electrical static in a sleeping brain. And your mind, stuck with the job, stitches those signals into a story so it isn't sitting there confused all night. Meaningless, but at least harmless. But a growing body of research says something stranger, something older. What if dreaming isn't noise at all? What if it's a flight simulator? What if it's overnight therapy? What if the strangest, least examined third of your entire life is doing more work than anyone gave it credit for? Let's find out what your brain is actually rehearsing every single night while you're completely unconscious of it. Every night, your sleep moves through several distinct stages, cycling roughly every 90 minutes. Light sleep, deep sleep, and then rapid eye movement sleep, REM. Your eyes move rapidly beneath closed lids. Your brain activity looks almost identical to being awake. Brain scans from this stage are genuinely difficult to distinguish from someone wide awake and alert. And yet your body is essentially paralyzed. Signals from your brainstem actively block the muscles in your limbs from moving, a safety mechanism so you don't physically act out whatever you're dreaming. That system usually works perfectly, but not always. In a condition called REM sleep behavior disorder, that paralysis fails and people physically act out their dreams. Punching, kicking, sometimes shouting, while still completely asleep. Doctors first documented it clearly in the 1980s, and it turned out to be more than a curiosity. In a significant number of cases, it appears years, sometimes decades, before the first tremor of Parkinson's disease, making a sleeping body, thrashing at 3 in the morning, one of the earliest visible signs of something, still developing quietly, deep in the brain. Most vivid, story-like dreaming happens in REM. Across a full night, your REM periods get longer and more frequent toward morning. The first is a few minutes. The last, before waking, can stretch past half an hour, which is part of why your final dream before your alarm goes off is so often the one you actually remember. For most of the 20th century, the dominant explanation for dreaming came from Sigmund Freud. In 1899, he published The Interpretation of Dreams, proposing that dreams were disguised wish fulfillment. Your unconscious desires, he argued, smuggled past your own internal sensor, dressed up in symbols so you wouldn't be disturbed by them directly. A staircase meant one thing. Water meant another. It was influential. It shaped a century of art, literature, and pop psychology. It was also, almost entirely, untestable. There was no experiment that could confirm or disprove a hidden symbolic meaning, which meant for nearly 100 years, dream science wasn't really science at all. Freud built an entire clinical practice around this idea. Patients would describe a dream, then free associate around each image, and Freud would interpret the underlying wish hiding beneath it. Two different therapists could hear the exact same dream and arrive at two completely different meanings, with no way for either one to be proven wrong. By the 1970s, neuroscience offered a very different answer. Researchers Alan Hobson and Robert McCarley proposed what became known as activation synthesis theory. During REM sleep, they argued, a small structure deep in your brainstem, called the pons, fires off essentially random bursts of electrical activity. Your cortex, the part of your brain responsible for meaning, receives this chaotic noise and does what it always does. It tries to make sense of it. It synthesizes a story out of static, the same way you might see a face in a cloud or a shape in a stain on the ceiling. Under this view, dreams aren't messages. They're your brain's best attempt at narrating its own internal weather. For years, this was the leading scientific model. Meaningless, but at least, finally, biological. Then, in the year 2000, a Finnish researcher named Antti Revonsuo proposed something that would reframe the entire conversation. He called it threat simulation theory. Revonsuo noticed that dream content isn't actually random. It's strikingly consistent. Across cultures, across centuries, certain dreams show up again and again. Being chased, falling, being unprepared for something important, losing control of a vehicle. If dreams were pure noise, why would the noise be this organized? Revonsuo's hypothesis was evolutionary. Dreaming, he argued, is an ancient defense mechanism, a virtual reality for rehearsing danger, built long before any of us existed. A 2006 study analyzing over 200 recurring dreams found that 66% contained at least one genuine threat, not abstract anxiety, specific, physical danger, rehearsed again and again in a completely safe, offline simulation. Later research pushed the theory further. Studies of children growing up in active war zones found their dreams contained more frequent and more severe threats than children in safer environments. Their brains appeared to be running the drill harder, because the drill genuinely mattered more. Across large collections of dream reports, fear turns out to be the single most common emotion recorded, with anger close behind it. Not joy, not affection. Fear, practiced, over and over, long before you're ever likely to need it. Think of it as a fire drill. Your brain runs without asking your permission every single night for your entire life, adjusting its intensity to match how dangerous your world actually is. Here's where it gets interesting. Threat simulation explains why we dream about danger. It doesn't fully explain why dreaming makes you feel better afterward. For that, sleep researcher Matthew Walker points to something happening chemically, specifically during REM sleep. While you dream, your brain's primary stress chemical, noradrenaline, drops to its lowest level of the entire 24 hours. At the exact same time, the emotional centers of your brain, the amygdala, the hippocampus, become highly active, which means your brain is replaying your most emotionally charged memories from that very day, but in the one biochemical state where stress itself has been switched off. Walker calls this overnight therapy. In one experiment, participants viewed emotionally distressing images twice, with either a nap or a period of wakefulness in between. Only the group that dreamed showed a measurable drop in emotional reactivity the second time they saw the same image. Their brain scans confirmed it. Calmer, amygdalus, identical memory, less sting. The memory itself wasn't edited or softened. Every detail stayed intact. What changed was the emotional charge wrapped around it, as if the brain had found a way to keep the file but strip out the alarm attached to it. It's often said that time heals all wounds. Walker's research suggests it isn't time doing the healing. It's the specific hours you spend dreaming within that time. This may explain why chronic sleep deprivation makes everything feel more overwhelming. And it may explain something darker. People with PTSD often show elevated noradrenaline even during REM sleep, meaning the stress-free window Walker described never actually opens. Their dreams don't get to reprocess the memory safely. They just replay it, raw, night after night. A drug called prazosin, originally developed for blood pressure, was later found, almost by accident, to reduce noradrenaline in the brain enough to ease nightmares in PTSD patients, accidental proof that the chemistry itself is doing real work, not just telling a nice story about itself. This isn't uniquely human. In 2001, a neuroscientist named Matthew Wilson at MIT recorded the brain activity of rats running a maze. Specific neurons, called place cells, fired in a distinct pattern depending on exactly where in the maze the rat was standing. Then he recorded those same rats, asleep. The identical firing patterns played back, in the same sequence, while the rats slept. Wilson could literally tell which part of the maze a sleeping rat was dreaming about. In a later study, his team found the replay sometimes ran backward, like a film in reverse, compressing a 4-second lap into less than 200 milliseconds. And in a further experiment, researchers played a sound associated with one side of the maze while the rats slept. The rats' dream content shifted, on command, toward that exact section of the maze. They had, in effect, engineered a rat's dream. If dreaming really is rehearsal, evolution built the system long before it built us. Rats can't tell you what a dream feels like. They can't describe fear or relief or the strange logic of a dreamscape. But their neurons don't need language to make the point. The same replay mechanism, the same reactivated memory, the same sleeping brain running through yesterday's experience, shows up in a creature separated from you by roughly 75 million years of evolution. Whatever dreaming is actually for, it's old enough that we inherited it, rather than inventing it. Every so often, something even stranger happens inside a human dream. You realize, mid-dream, that you're dreaming, and you don't wake up. In 1980, a researcher named Stephen LaBerge set out to prove this was real, not just a nice description people gave after the fact. He trained volunteers to recognize when they were dreaming and to signal it, using a code almost nobody could fake by accident. Specific, pre-agreed eye movements, left, right, while their eyes were being recorded on a polygraph. The signals showed up exactly when the dreamers said they would, during confirmed, unambiguous REM sleep. For the first time, a person could report from inside a dream, in something close to real time. It's a strange thought. Somewhere inside your own skull, there's a version of you that can, on rare occasions, turn around, notice the dream for what it is, and keep going anyway. Fully aware, still fast asleep, still generating the entire world around itself, second by second, with no external input at all. Most nights, that awareness never switches on. The simulation just runs, uninterrupted, exactly as intended. So why do you forget almost all of the rest of it by breakfast? During REM sleep, a brain chemical called acetylcholine surges, sometimes to 4 times its waking level, while activity in your prefrontal cortex, the part responsible for logic, time, and forming new long-term memories, drops significantly. You are, quite literally, experiencing vivid, emotionally rich content with the exact region that would normally file it away for later, running at reduced power. Some researchers argue this isn't a flaw, it's a feature. A rehearsal system doesn't need you to consciously remember every single drill. It only needs the underlying pattern to be practiced and quietly reinforced, somewhere you'll never consciously access again. The lesson gets kept. The footage gets deleted. It's a bit like a fire drill at a school. Nobody expects the students to remember the exact conversation they had while filing out of the building. What matters is that their legs know the route without thinking. The next time it actually matters. Your dreaming brain may be optimizing for the exact same thing, the reflex, not the transcript, but not always completely. In 1865, the chemist Friedrich Kekulé had spent years failing to understand the structure of a molecule called benzene. Then he dreamed of a snake, curling around, biting its own tail. He woke up and realized benzene wasn't a straight chain of atoms at all. It was a ring. The insight reshaped organic chemistry. For over a century, this was dismissed as a charming anecdote. Then, in 2009, researcher Denise Kai tested it properly. Volunteers solved word association puzzles, then either napped, rested quietly awake, or stayed in non-REM sleep. Only the group that entered REM sleep showed a measurable jump in solving puzzles, built from the same hidden connections, even ones they hadn't consciously cracked before napping. REM sleep, it turns out, is unusually good at forming loose, unexpected links between things your waking mind keeps carefully separated. Kekulé's snake wasn't magic. It was his own brain, freed from its usual filters, quietly reorganizing what he already knew into a shape he'd never consciously considered. So here's where all of this actually lands. Dreaming probably isn't one thing. It's a rehearsal system for physical danger, inherited from something older than us. It's an overnight therapist for emotional wounds, running on its own private chemistry. It's a search engine for connections your waking mind is too orderly to make. It's a signal, reliable enough that a sleeping body can sometimes tell a doctor what's coming years in advance. And it's a memory process old enough to show up in the brain of a rat, running the same maze for the 100th time. All of this, running quietly, for roughly 2 hours, almost every single night of your life, whether or not you ever remember a second of it. The version of you that wakes up tomorrow will have rehearsed a version of danger, processed a version of yesterday's emotional weather, reorganized a few stray connections you didn't know you were missing, and reinforced memories it will never show you the receipts for. You won't remember most of it. That was never the point. The point was never the memory of the dream. The point was what the dream did to you, quietly, expertly, while you weren't watching. A rat running a maze, a chemist staring at a snake, a soldier's nightmare finally losing its grip, a sleeping body flagging a disease years before anyone thought to look. None of them needed you to remember the details for the work to count. Tonight, somewhere around 2 in the morning, it will happen again.